intro, seconding everything she just said. There's a lot going on at ETHDenver. It can be a little overwhelming, but please do take the time to explore. Make sure you get over to the Biddle Hub on the other side. Make sure you see the Zen Zone upstairs, food trucks, lots and lots of stuff going on. I could not be more excited to be here. I've been at most of the ETHDenvers. They've gotten bigger and better every year. Really excited and honored to be here and just have an opportunity to share the space with you guys. My name is Lane. I am a developer working on a project called Spacemesh. We are going to talk for the next 20 minutes or so about a topic that is near and dear to my heart, hopefully to yours as well, decentralization. It is a term that we tend to throw around all the time without always being very thoughtful about what we mean by decentralization. And so my goal here is to talk about things like how we define decentralization, how we should think about it, right? Why it matters so much, and also how we measure it. And then I'll also talk a bit about decentralization in the context of the Spacemesh project. Okay, good. So tiny bit of background on myself. I've been in the Ethereum community since 2017. I worked as an Ethereum core developer with the Ethereum Foundation for a couple of years. I was initially attracted to the Ethereum space, and I should mention as well, the first ETHDenver is one of the main events, one of the main reasons that I decided to join this community full time. The thing about Ethereum for me and other blockchain platforms and just kind of the bundle of ideas and technologies is that it's an opportunity for democratization, right? I have a background in traditional finance, and I've always thought of Ethereum as an operating system for building better human institutions and as a platform for building, let's say, value creation networks to allow people around the world to participate in a credibly neutral, decentralized fashion to create value for themselves, their families, their communities. That's very much what I've been focused on over the years. I joined a fledgling Layer 1 project called Spacemesh in 2019. That's what I've been working on since then for the past 5 years. The biggest and most important piece of news I have to share about Spacemesh, although it's not exactly new news at this point, is that after 5 years of grueling R&D, we finally launched the mainnet in July of last year. And I'm really excited. This is the first ETHDenver when I've been able to say Spacemesh is now alive. Really, really exciting. If you have not had a chance yet to kind of check out Spacemesh, to download the software, to join the network, to mine, et cetera, from home, now is a great time to do it because the network is much more mature and more usable than it was 8 months ago when we first launched. Yeah, it's been an exciting few months and few years. Spacemesh, I should mention, so we have 2 primary goals with the project. The first is to become the most decentralized blockchain in history. I think we are well on our way on that journey, and I'll share some updates in a moment on how it's going. And the second goal is to enable ordinary people around the world to join the network as miners, right? Not as a light client, not as a full client, but actually as a full mining peer, a validator on the network using existing hardware, whatever computer you have, whatever internet connection you have, and to do that sustainably and profitably. And actually, those 2 goals are the same, right? In order to have millions of miners on the network, it needs to be very easy for home miners to join the network. So that's what we're working on at Spacemesh. So in the next few minutes, we'll talk about first some remedial 101 on decentralization itself. I'll talk about how Spacemesh is doing towards that goal. Talk about some of the challenges we're facing on the roadmap to decentralization, how we're addressing those challenges, and kind of looking forward to the future of Spacemesh as well and how we're going to improve. So first of all, what is decentralization? Again, just to reiterate, it's a very important idea. It's kind of the reason we're all here in the first place, right? Remember why you started. But again, it's something that we don't always communicate about very thoughtfully or very rigorously. So our dear friend Vitalik actually has what I think is still the best answer to this question. He posted a post on his Medium 7 years ago. It's a lot of years in crypto years, right? Called The Meaning of Decentralization. I could easily spend an hour just talking about this. Obviously, we don't have that much time today. I strongly encourage you to read this article if you haven't. I also published a Substack article. I have a Substack. I'll have the link at the end, where I did some deeper analysis and reflection on this as well, more than we can get into today. But we'll just do a very, very high-level overview. So the first 3 here, and just to be clear, in this section, most of these ideas are Vitalik's ideas. I'm just going to kind of add some commentary and a few kind of tweaks. So he splits decentralization up into the first 3 categories. I've added the 4th one. Logical decentralization is kind of like is this thing a monolithic entity, or is it more like a amorphous swarm? That's the term he uses. Blockchains are only useful if they are logically centralized, right? So this is why it's so important to understand decentralization, because actually there are aspects in which, ways in which we need blockchains to be centralized. They need to be logically centralized to give us something like a single ledger, a single view on truth, a single state machine in the case of Ethereum. Architectural decentralization, this is going to be the focus of this talk. This is mostly what we mean in this community when we talk about decentralization. A very reductionist view of this is how many nodes are there on your network. We'll analyze it a bit more deeply later. And then there's political, and I added economic to this list. I added economics specifically because in the context of proof of stake, I think it's very important to understand things like the Nakamoto coefficient, which is an imperfect metric, but it tells you the number of validators that would have to collude to halt a proof of stake network. But basically, it's like how many decision makers are there? How many doors do you have to knock on if you want to like change something or stop something? But again, we're going to focus on the architectural primarily here. And the second piece of his article talks about why decentralization matters, also a very important question. Again, important, very nuanced. We don't have time to go deeply into this right now. But fault tolerance is non-controversial, fairly obvious. It's sound engineering practice. It's been a thing since way before blockchain. Attack resistance, I think of as a specialized case of fault tolerance, where the faults that we're trying to prevent against are intentional rather than accidental. And collusion resistance, I'm not even going to go into this right now. It's, again, like super, super nuanced and super complicated, but it's another goal of blockchains in general and definitely a goal of Spacemesh. Cool. So let's jump into the kind of concrete piece here on Spacemesh and how we're doing. You know, every talk I've given about Spacemesh at this event previously has always been like a theoretical talk, and I'm just so thrilled that this is more of a in-practice talk because the network is now live, and we'll see some live numbers. So we have this thing called the network dashboard. If you go to dash.spacemesh.io in the web, or just Google Spacemesh dashboard, you'll find this. I don't know if this has a laser pointer. Yeah. So we have some exciting metrics here. You'll see a lot of these kind of like hockey stick shaped graphs, which is really, really exciting. So we have now more than 1.3 million smeshers on the network. I'll talk about what this means in a moment. You know, transaction volume is growing steadily, circulation in coins, security. I'll talk about this in a moment as well. There's no feeling more satisfying as a builder and as an entrepreneur than to be able to stand on a stage and put up a slide like this. I mean, this validates, this is our hockey stick graph, right? This validates all of the hard work, the blood, sweat, and tears that we've been putting into this project for 6 years. So let me explain what this means, right? So we are, obviously time on the x-axis here. The y-axis is what we call miner identities. So we have over 1 million. I think we're actually, what did this last thing say? 1.33 million. These do not map directly to miners as we think of them, in the sense that these are not like people or organizations or computers on the network. The way the Spacemesh protocol works right now, it's very common for a single miner to have a dozen, or in extreme cases, even hundreds or thousands of identities, which just refers to like the individual plots of hard drive space that they're committed to the protocol. So, you know, I wish I could say we have 1 million miners. I won't make that claim. We have millions of miner identities. It's probably a couple orders of magnitude less than this. We don't know the actual number of exact miners, but really healthy growth. Another hockey stick graph, right? So this is the security. Spacemesh uses hard drive space for mining, unlike proof of work, unlike proof of stake. We are at, I believe, 1.3 exabytes with an E. That's a crazy number. Like, just, I can try to give you some sense of it. It is 250 million songs, which is twice the size of the entire Spotify catalog, right? It is also 10 times the entire storage of the Internet Archive Foundation. They've got 100 petabytes of storage. We're 13 times that right now. We're about 60% of the size of the storage, the actual data being stored on Filecoin. And I think this is insane, given that we only launched this network 8 months ago. And if you were to 51% attack Spacemesh, you would need to have at least this much space. So that's why this is our security metric. This is actually the most interesting of the 3 slides I'm going to put up, in the sense that this does map more or less directly to like a real-world thing, and that thing is unique peers or nodes on the network. This is kind of imperfect. The data here is kind of like smooth and aggregated, so like don't pay too much attention to the dips and the bumps. But you know, we're at around 20,000 unique peers on the network, public peers, right? The number is actually higher because, and we don't know how much higher, because not all of the nodes or miners or peers in the network are visible to us, to our nodes. Many people are running private nodes and private internet connections, et cetera, behind routers and NAT and things like that. But this is significantly more nodes than are live today on Bitcoin or Ethereum, right, which are both in the order of thousands, not tens of thousands. Again, I'm very proud of this. Still some healthy growth here. We want to get this to 1 million. That's our goal. OK, so back to the dashboard again. I didn't bring this up before, but we have this weird thing down here called a decentralization ratio, right? I talked about measuring decentralization, right? What does that mean? It says 81 out of 100, so I guess we have like a B- right now. This is a fairly arbitrary metric that we threw together. It, in no way, shape, or form, is like perfect or doesn't capture all the dimensions of decentralization by any means. It's this kind of like subjective metric we came up with for now, which is a weighted average of two things. The first is the number of those miner identities, and the second is a Gini coefficient, which I think is very interesting, right? You'll recall I mentioned economic decentralization. So it looks at the Gini coefficient, which is a measure of how evenly or unevenly distributed wealth or income is in a population. So in our population of miners who have produced blocks in the past 100 epochs, what's the Gini coefficient of that number? There's a bunch of kind of arbitrary, I keep using the word arbitrary parameters here that we set. I wouldn't say we're 80% of the way on our goal to decentralization. I'd say we're 10%. So we need to improve this, but this is all open source, and this is just like a conversation starter. I wanted to share. I'll do another talk on just this topic in the future. All right, so let's talk a little bit about why decentralization is hard, right? That was the subject title of this talk. First reason, home miners. Every other blockchain network, layer 2, layer 1, whatever, that I'm aware of, has one thing in common, and that is that they have professional node operators, okay? They're experienced people who understand DevOps. They're running Linux, right, in real data centers. Spacemesh has none of this, okay? Our whole goal, and the only way we're going to get to 1 million nodes, 1 million miners in the network, is by making it really easy for everyday people to download an app and just minimize it, run it, set it and forget it. But that presents a whole bunch of obstacles and challenges. You need to keep your computer running 24 hours a day. That's not that easy if, again, it's not a Linux VM running in a data center. It's your actual gaming computer, right? There's high resource requirements, which we'll talk about in a moment. There's frequent upgrades, things like this. Home users, unsophisticated users, are not great node operators. Our mitigation here is that we need to improve the UX of running a node a lot. We're a bunch of back-end systems engineers. We're not product people, but we are hiring product talent onto the team, and we're going to make this like a really fun experience for our users. Peer-to-peer, let's talk about this. Again, every blockchain network that I know of runs on peer-to-peer, but peer-to-peer is much easier when those nodes, again, are things like Linux VMs and data centers, rather than Windows machines sitting on people's home connections. Unfortunately, I know a lot more about routing protocols on the internet than I ever wanted to know about. This is one of the biggest challenges we have. But one of the fun facts I've learned in the past year or two is that the internet, the modern internet, is not designed to make peer-to-peer easy, right? There's all sorts of like dark design patterns and hostile design patterns, the way that ISPs run, the way they put, in some cases, tens, hundreds of thousands of nodes and home internet connections behind a single IP address, which kind of fundamentally breaks things like TCP/IP. The majority of nodes in our network are not routable, they're not dialable. It's challenging, but the good news is that we have some really wicked, low-level P2P network engineers on our team, and we know how to improve these things. There's amazing technologies. We use libp2p. libp2p has got some fantastic protocols to do hole punching, things like this, so this will get better. Resource requirements. Again, we want it to be as easy as possible for any ordinary person to just run our software on their computer without worrying about their CPU, their memory, their bandwidth, et cetera. Unfortunately, the requirements are pretty high right now. The way the protocol is designed right now, every time a new miner joins the network, the complexity goes up, right? So it grows linearly in the number of miners. Each miner submits a proof each epoch. Every node in the network has to download, validate those proofs. That's very bandwidth heavy. It's very computation heavy. And this is one of the reasons it's become very hard to join the Spacemesh network as an unsophisticated home miner. We expected, best case scenario, 10,000 miners. And as I said, we have more than 2 orders of magnitude more than that right now. This is our biggest challenge right now. We know how to fix this as well. We are working on protocol improvements like distributed verification, which means that each node will only be responsible for probabilistically verifying a tiny fraction of those proofs rather than all of them. But that's core protocol research and development, and that will take time. So it will be months until I think this burden gets easier. OK, everyone's favorite topic, pools. Again, I could easily talk for an hour about this. It is very complicated, very nuanced. I'm thinking I need to kind of do a talk on this as well. It's a very controversial topic in the Spacemesh community. Another fun fact I learned recently, the first Bitcoin pool launched in, anybody? First Bitcoin mining pool, what year? Any guesses? 2010. Crazy early, OK? Pools have always been a reality for every protocol that I'm aware of, every permissionless decentralized protocol, Bitcoin, Ethereum, proof of work, proof of stake, it's a thing in Spacemesh as well. The unique thing about Spacemesh is that, I said many times, our goal is to make mining easy for home miners. In proof of work, if you have one Bitcoin ASIC, one modern Bitcoin mining machine, you will produce a block on average every 30 years, okay? That means you have to join a pool in order to earn any rewards. In proof of stake, in a network like Ethereum, you need 32 ETH to run your own validator. That's a lot of money. That's out of reach for 99.9% of people on Earth. So again, you have to join a staking pool. Our goal with Spacemesh is decentralization, democratization. Every miner, even the smallest miner, receives at least one reward every epoch, every 2 weeks. Right? Let me say that again. This is kind of the most important fact about Spacemesh. The smallest miner on the network receives a reward every 2 weeks, at least every 2 weeks. It's guaranteed by the protocol. It's deterministic. It's not probabilistic. And that's why Spacemesh took so long to build. But there are non-economic reasons to join pools as well. This is something else we kind of didn't forecast, such as the things I was explaining, the fact that it's just a little hard to run a node from home right now. Our mitigation here, I mean, pools are not going to go away. We need to educate people about the trade-offs, the risks of using pools, such as giving away your private keys, not a great idea. We need to make it easier to operate pools, so there are many of them, rather than a single pool. And we need to reduce those non-economic incentives to join pools. So we're working on this. I think this will get better over time. And finally, economics. So that small home user, the minimum storage space right now is 256 gigabytes, right? If you have that minimum committed to the network, you're earning about $1 US per epoch. That's every 2 weeks, $2 a month. If you have 1 terabyte, you're earning about $8 a month right now. Of course, there's a lot of variables here. As more miners join, it goes down. The coin price obviously moves around a lot. I highlighted this. This is a screenshot from a mining pool called H9. Per petabyte, so per unit space, it's, as you can see, like Chia is in the order of $9 per petabyte. Spacemesh is 358. This is after that crazy exponential growth you saw. So it's come down a lot. But it has at least another order of magnitude to fall. So that we can expect economically, again, depending on things like how the market does, the storage size of the network to at least 10x, if not 15, 20, 30x, et cetera, before we expect the market to find equilibrium, which means those rewards will continue to fall. There's nothing we can do about this. There's no mitigation. This is just kind of economics. But it's going to be exciting to see where we go from here. OK, let's go into kind of the final section, which is how we do better. So I've already covered all of these things, just reiterating. We have kind of these low-hanging fruit changes, things we know we need to improve to make Spacemesh more decentralized. We need to improve the product experience, improve P2P, make it easier to run a node from home, to sync a node. That's a bit hard right now. We have this set of protocol upgrades that will have the effect of reducing those resource requirements, making it much, much, much easier to run a node, and we think then also reducing the impact of pools in the network. We want to, again, encourage, we know pools are not going to go away, right? Spacemesh is a permissionless protocol. We can't shut down pools even if we want to, but I think a better approach, I kind of like the approach the Ethereum ecosystem is taking to MEV, right, with things like MEV Boost. We know we can't shut down MEV, so the best thing to do is democratize access to it, increase education, et cetera. I think we can do this with pools in Spacemesh. And as I said before, education, education, education. People need to understand the risks and the trade-offs of things like joining a pool. The next step is the VM. Again, could spend an hour here talking about this. I'm a VM engineer. This is the piece of Spacemesh I'm the most excited about. We have been working on this for years, for 5 years. We built a full-featured WebAssembly-based VM called Spacemesh VM or SVM. We threw it away because the goalposts have changed and the landscape has just evolved so much over the past few years. This is just a kind of a random snapshot of like the things you need to be thinking about right now if you want to design a smart contract engine or a VM in 2014. There's a lot of stuff to figure out. There's different VM choices. There's modular versus integrated. There's layer 1s and layer 2s and rollups and different types of rollups and different types of sequencers. There's ZK considerations where we want to be future-proof. We are having a research summit in a few days. And we expect to, I can't promise we're going to make a final decision, but I hope we will. And we're going to have a lot to share on this very, very soon. But this is the next phase of Spacemesh once we've kind of stabilized things with those earlier improvements I listed. And finally, going back to the very first thing I said, right? The whole point of this, why we're here in the first place, is to build these global, decentralized, permissionless, credibly neutral networks where ordinary people anywhere in the world, regardless of the extent to which you're enfranchised by existing financial networks, can join, create value, generate value, distribute value globally, right? You can think of it as decentralizing social media networks that we have today, right? Removing those rent-seeking centralized operators. I've always seen blockchain as a platform for this, and I think this is my set of criteria. I just kind of came up with this. I don't know if it's perfect. Let me know what you think. I'll write and speak more about this. But number one, the thing we're measuring, the thing we're proving, should be widely endowed, right? That means it should be a thing that is accessible to humans everywhere, right? Number two, it has to be objectively measurable in a decentralized way. Why? Because the protocol is the only thing that can do that in a credibly neutral fashion, as opposed to having human arbiters, which is, again, the whole point of decentralization. Ideally, it's not too gameable by machines. This is really a touchy subject today with the rapid advances in AI. And ideally, it's the extent to which it's subject to those economies of scale that I mentioned is not too severe. So actually, hold on. Before I jump to that, how do proof of work, proof of stake, proof of humanity, things like that do here? Not super well, right? So proof of work, proof of stake are not super widely endowed. There's not that many people who have 32 ETH or Bitcoin ASICs. Those things are pretty gameable. Proof of humanity, there's a number of these projects. I won't name any specifically. The biggest issue is they're not necessarily measurable in an objective and decentralized way. If you're scanning eyeballs or something, like there's no way for a protocol to do that in a decentralized way yet. Maybe someday we'll have it with zero-knowledge proofs. I think we can do better. So as I've meditated on this for many, many years, the thing I've come up with is this idea. And I'm just painting a very broad picture here. I think of it as proof of creativity. I'm not the first person to come up with this idea. There's New Foundation and other projects have been working on this and have gotten further than I have. But I do think this is the goal, right? I think that the thing that checks all these boxes as much as possible is creativity, right? It's very widely endowed. There are creative people, talented people all over the world. You don't necessarily need an education, a credit card, a bank account to be creative. It is not immediately obvious how it's objectively measurable, but if you think about the way social media networks have tweets and likes and warps and all this kind of fun stuff, I think that is a fair starting point for objective measurement. This next one is very controversial. I'm going to go out on a limb and say that I don't think that AI tools are able to compete with humans at this moment, nor will they be in the near future in real creativity. Controversial topic. I'd love to have that debate. I could be wrong, but I have a good feeling about that. Real art, real writing, things like this. And to what extent is creativity subject to economies of scale? I mean, this is debatable, but I think it's less subject to it than some of the existing protocols like proof of work and stuff. So that's all I've got. Thank you so much for your attention. I have a vision that we'll build Spacemesh into a proof of creativity network, so stay tuned. We have our work cut out for us, but that's where we're going. Some resources. So I mentioned a Substack. I write about all these topics, including Spacemesh in long form, so check that out. On Twitter, I'm very much a boomer, but I'm now on Warpcast as well. Shout out to Warpcast. There's a meetup later today, I think, right? And yeah, Spacemesh website, and join our Discord, chat.spacemesh.io. I hang out there. I'm going to leave you with a quote from one of my personal heroes, Jaron Lanier. Anyone who's not familiar with Jaron, he has a number of excellent books on this topic. He is the greatest thinker in the world who has thought deeply about the dangers of centralized social media, centralized networks, centralized technology. This is our goal, is to solve this problem. Thank you.